All right, hello everyone. We're going to be doing a little bit of stuff with electric charge. We've already done gravitation as part of the first unit, but we want to make sure that we can cover some of the other fundamental forces. So I want to do a couple of different things, talk about what is electric charge and what are conductors and insulators. So the first thing is, what is electric charge? And the first person who actually talked about positive and negative charges was Benjamin Franklin, and he came up with the idea for the test, the famous kite and thunderstorm test. Basically, the first person who did it in 1752, you didn't have lightning strikes, but he was able to definitively show that the charge built up in a thunderstorm was electric and not just fire. We now know that electric charges are based on what's going on inside the atom, the subatomic scale particles, protons, neutrons, and electrons. Protons are positive, neutrons are neutral, electrons are negative. But in terms of what we actually deal with, it's the electrons that are the only particles that move. So if something is positively charged, it means it lost electrons. If it's negatively charged, it gained electrons. So one way of doing that was talking about an object that could either donate electrons or gain electrons. And then the basic idea that they found is if you have like charges, they will repel while opposite charges attract. You can do a quick experiment with a piece of tape. If you take two pieces of tape and put the sticky side together and then pull them apart very quickly, you'll see that one of them will become positively charged, one will be negatively charged, and then they'll be attracted toward one another. But if one gains an amount of charge, Q, the other one will lose that same amount of charge. Now, when we talk about electric charge, we either use lowercase u or capital Q, and the SI unit for that is the coulomb. 1 coulomb is about 6.25 times 10 to the 18th, either protons or electrons, positive or negative. But then we can break down the types of materials that we have. Are conductors. Conductors are basically anything where electrons are free to move. They have a high conductance. They're able to do that. The electrons are shared between atoms, and they can move from one place to another without much resistance or much kind of stopping them. An insulator, on the other hand, is a material kind of like glass or rubber or plastic, where generally the electrons are held in place so they don't move very easily. And then a semiconductor is when there are a lot of different factors that can change whether or not it's a conductor or an insulator. So generally conductors are metals. Semiconductors are along that transition line between metals and nonmetals. But inside a conductor, the electrons will move kind of so that any excess charge is about the surface, where an insulator usually just stuck in place. Like if you've ever rubbed a balloon on your hair at a party and stuck it to a wall or something like that. Basically, there are electrons being removed there, and so you gain a local area of positive charge, and then that's able to stick to a wall. We can charge by conduction or charge by induction. These you can see basically by conduction, meaning you're directly moving objects from one force to another. And induction is to kind of push things back and forth and then allow it to become charged. So if you do the balloon and sweater and wall simulation that's part of the lab, you'll see that. Then I'm going to add a couple of previews to some of the quiz questions that you'll get. But if you have an object suspended from a string, attracted to a wall, and that object is positive, what must be true about the wall? So is it uncharged? Is it positive? Is it negative? Or negative, is it positive? Or do you need more information about it? So basically from that is one of the quiz questions that you will be getting later. And then I'll have some explanation.